because we need to see exactly what currently happens in the for us as a team, we also need that technology to be able to assess our own build UAVs to see how they perform during the flight. There are many methods to do it. So, for example, using the SHOT or the SD card system, you can start issuing that after the flight. However, due to our research, these flight is we found out that sometimes we go into the city damage to most people to protect it, basically. So to cut off all the because right. Now, sometimes it's because of the data loss. That's why we have other methods such as wireless projection. We know of radio projection, which is the most common one we use. The issue is we need to have a ground station specifically in a direction where it's within range of that. So in UBM, we decided to build our own thematic system, but using cellular connectivity, the same SIM card that's on your phone can power up the phone. So we had two objectives for this project. So the first objective is to develop a system that is able to capture and store the data and send it. So for that, to achieve this, we started by first benchmarking the available prototypes. We have found tools, Arduinos, Raspberry Pis, and we have decided using because it's a very powerful system. This one is a custom built board by Marino Development. They make this board alongside other development kits. We selected this one based on our criteria. This one is the ESP32 combined with a modem, A768 Syncron modems. The reason why we selected this modem is it supports also GNSS. So we both have GPS and the ability to transmit that data. So after we benchmarked, we selected the most got the design requirements, and then we went for any contributions that this system may have. And how do we solve it? So one of the main contradictions we had was the weight. You don't want to have too much weight on a small UAV. So we decided with the compact system, combining every component. Instead of having ESP32 standalone, different components standalone, we decided to combine everything. So we came up with this. This module, this is the dimensions for that module, and it weighs around 140 pounds. You can carry it around with it. It's already set up, so you can put directly on UAV. And we did actually put it in UAV, you can see from this way. We put it on that one, and then we flew it. So this is the live generated feedback from that UAV. So during the flight, we were keeping all that recording. Also, this system also supports sleep recording. So our platform is also customized. You can access it. The idea for this is first the module starts. We'll send data to the website to get a request. Once it gets a request, there's a specific series of code telling it that this is the flight. This is the flight code that you're operating on. So you know, like tail numbers. So to assign every time a tail number to different flights.
Maybe like the same thing. I would say, I mean, each flight
a new one. So let's say I did a flight yesterday, I want to memorize what I did, so just so I can note it down. And even if I didn't note it down, I can just go to the replay, because again, for a black box, it has to store the data upside down. So I'll just go over here and you can see when the data was stored, when the data was started, and how much points we had. So in the morning, I started this module, and select this one. This one is what I said. Actually, there's actually no one. And we can show you the entire data set. You see, it has 4,000 rows, see what happened by the moment of flight. So you can really imagine how the flight has been done. Similar to this module, you can see flight the drone, you can see how the replay system is active. It will really help you really imagine how that process happens. So between these two, we send first the database, and then once the database organizes everything, so it will display the user. This entire process is done in 1 second. So from the moment it captures that data, sends it to the database, and it gives it back, this whole process is only 1 second. So it's quite fast compared to radio telemetry. And we can see the benefit, actual benefit from radio telemetry. So we did a test. We hypothesized, okay, what happens if we do radio versus satellite? These are the points generated by this module. These are the line that is generated by a big sock connected to radio. As you can see, the radio is very fast, and this one is also very fast. However, when we reach this point, you'll see the radio cuts off. But our system is still capable of recording this data all around. The issue here is there is interference here because there is a lab, communication lab, and it uses a lot of radio frequencies. So we cannot really judge on this. However, once it comes back to the radio, it will start disappearing. And that's the major benefit that we need for this test. And we have done this test actually. We wanted to see how is the system performance compared to not just radio, to its own self. So that's the option number 3. So what we start is we send the data through the model, and we send it also through the SD card on board. We want to compare. For the data on the model during this study, we got 4,000 data points. Through the SD card, we got 43,000 data points. So it's like almost 10 to 1 ratio. But that number might not be impressive. However, the readings are impressive because throughout an unintended purpose, we were able to actually do a trend analysis for this one axis, the raw reading. So you can see the orange one is from the website, the blue one is from the SD card. As you can see, the SD card has a lot of noise. The website somehow filters out that noise while keeping the trend. So you can see specifically in this the website gives out the average of this point. So it's unintended filtering, which is a very good point. And we process the data, we provide it back to the user, and now let's say right now you want to see what happened in the flight. So it will drop a flight path for you to see what happened in the flight. Of course it's stationary, so you could do much. So you can see like how it operates, and plus you can even try with the module. The module actually is equipped with 4 parts. One is the light source. So if you have a 3S battery, which is most of the way we use, and you will get the reading over here. Right now there is no battery, so it will read your ball. They have also the GPS system, which you can see over the map. We also have the high wave, which gives us the pitch, roll, and the audio. Try to play around with it and see the latency. It's a bit laggy, but you see it will snap right away. And plus, because we want to do further analysis, some people will say, okay, we fly the drone, but sometimes the UAV, for example, we say left, but it doesn't move left. So how do we determine this? We say we use the radar signal, we hijack it and listen to what is happening. So right now, let's say I'm doing throttle up. So let me go to the channel. You can see this channel, this one right here, is the throttle. So hypothetically, by this scenario, we see that the throttle is there. So the aircraft should probably throttle up. However, some cases it won't. So we know now it's not an issue from the system side, it's more of a mechanical issue with the propeller or the motor. This is most prominent in cases where the aircraft is told to pitch right or left or up and down, but the response is not there. So we want to know if the issue is from the flight controller, from the remote, or from the signal receiver. So you can see the numbers over here. This one corresponds to different channels. It supports up to 10 channels. Even if we put a 6 channel, it will still be displayed correctly. you can try different signals, you send them over here without 1 second delay. And we also completed a specific module. We said we have a lot of people who want to invent their UAVs, who want to create something. So what we've done is, we said, why not make an AI? This stuff can AI. Let's say right now we're doing a flight, right? So this is the control this one. This one is like this. So no other device can control this except for this one. For security reasons. Of course you don't want some person to reset the flight. Yeah. So let's say I want to test right now what happened. So we can say, check if this flight was live. So it will generate now a list of live flights. And then you can analyze whatever flight you have. Let's say I want to analyze a flight. Let's say this one. This AI is actually linked to our database, so it will still be able to read what's happening.
Everything is cloud-based.
Everything is cloud-based. So the aircraft crashes, you don't know where it is, you can still find it. And the benefit of this system is it actually treats it like a black box. So when the aircraft crashes, let's say you have lost control, you don't know where it is. It flew overboard. How do you find it? Usually you have to go around the country trying to find it. That's what you did actually. So you have to go around trying to find it, get the connection. But of course, the picks up, it will distract every component. So how does this work? It will stay up to 2 hours extra from that time of crash. So it will stay on, giving you the pin or indication of where it is. So as an example right now, we did this test. We did this test where I used my phone. I have an iPhone 15. We used the iPhone. I don't know if you have heard of it before. That one. And it took both of them and ran around the campus of the university. You can see the accuracy of the GPS. How maps around the system. However, there's a bit of an issue. Why? It's because we are in a heavily distributed building. This is a 5-story building, so all GPS will stop. However, the module will regain its ability right after you exit that area. So it's still we did ask me, you know, I gave you the data points. You will say, these data points look like a drone. Right now you see it look like a drone, you know, drones surveying the specific task. We gave the data to AI. It right away knew this was not a drone. It said this was a human-made projected flight. So it identified just from the precursors of what is happening. So we give it the code, we say analyze, and then we let it go to ask our database to start to read whatever is happening in the flight, and then we can provide a response. So, okay, the system was on since 10 a.m. With this, stationary condition. We'll do the flight. We also just ask different questions. First is the human versus drone. So we give it an actual drone flight, one we did, and human, of course. We ask which one of these flights is human, which one of it was drone. Even though the human mimicked the drone's actions by rotating exactly like a drone, hovering up, it identified it correctly. And with that as well, we also did ask the AI. You see this car? So this one's big budget. We gave it the data set for this discussion, and we asked it to compare it with the data set from what the model said. This helps a lot of projects. Let's say, for example, you want to get the chart right away, but the issue is you don't want to like go through Excel, do everything. The AI will do it for you. And right now, while we're talking, it's still doing the analysis for whatever this flight has been done. So this is the entire project. You can also scan the you see for yourself. The benefit from this is when you you just put this on the way you have your phone. That's it. Don't need translation.
I would say, to my knowledge, the current UAV flight time will be about half an hour. So this affects the flight time.
Okay. In terms of critical consumption, no, because it's still separated from the system. Once it turns on, so this is an 1060. It should last more than 2 hours actually. But what we say 2 hours is for a safety factor. You can also see the user manual. We have printed 4 languages. So Arabic, English, Chinese, and Malay. So this is the entire project. It supports 2 SDGs, the SDG 9 and SDG 11. We aim to provide for a sustainable future. So how we achieve that is by analyzing what we have done and improving based upon that. We started this prototype, so in hindsight, it should have been more problem. This is what we have done. So you can see it's a very shell with a component using a remote controller to the device. However, we decided we wanted to go for a professional way. So we started with a PCB.
So this one
This side, we designed it itself, and we sent out to DLC PCB to print out the PCB parts. So and then the paper they have added a thread. So this is the exact same board, but after the control and because I just kind of selected my resistors, so the margin of plus the and then but yeah, I just have done fine. You can actually support that if you want. This is a competitive. So this is an ICM 2098. So this is the most common use. So with that, we can actually select which one we want to do. We did the case study that time. We did 2 items. We have this. We compared it. So basically, the percentage for this is 2.4% error. This one is 6% error. We did that case study. And what we discovered through the case study is what AI will say, oh, these two will work together. It's okay. This one will work better. Through this worked better, but because of reliability issues when it's starting, we prefer to use the most reliable operator. We sacrifice the accuracy for reliability because in aerospace everything has to be reliable, and that's where this part comes in. That's why it's the most important part, as you can see. Trace helps us to dictate which one we should, which decision we should select for a specific part of the project. And then once we have developed this, some people may not like they just want to get just the raw data, just want GPS. So the code for this is actually highly modular. Have you insert this to know I didn't the V1. You insert this, what it will say it's V2. Insert only this, it will not go only to GPS mode. So it's highly modular. It has been accounted for all parts.
So it's based on the design
Okay, that area. Design on the different components. So right now we implement and this sensor. I know what sensor I'm using, so I'm going to go back to the V1 design. So if it knows I'm using a high advanced sensor, okay, now I'm using a if there is no sensor at all, it will know to go to just GPS and move more because it heavily relies on that.
It depends on which one you're connected to, then it detects from there.
Yes. So that's why this module design is kind of modular. And for advanced so you think about this project? In your honest opinion.
So it's gonna have
There are some, I would say, used before for even my FYP projects, not FYP, slightly before FYP. Like the ESP
one
used before.
so everything you can see here, the stall angle, right?
For my case, it's actually more, it's kind of similar to you. I did UAV, but I'm more for programming using MATLAB.
Nowadays they have like fly-by-wire.
No, SolidWorks, all those to draw map out my path. So, but this one is, I think, even the next level.
I understand, because it's a big project, I would say, but to be honest, the outcome was worth it. But when we seen drone fly, that was a very happy achievement for us, because not only we prove that it works in laboratory conditions, we also prove that it works in real life situations.
Just curious, this film trace is it comfort?
No, it's my only
when you
So it's nickname we picked. Falcon is because of my Arabic heritage, and falcons are very prominent back in my country. So we decided to go with falcon face. Very serious because the facts being shells.
So do you plan to, I mean, take it to the next level in future, like yes, you continue to develop and like make this a real thing? I feel like the picture.
There is actually a chance for the next step where we want to integrate this with the fighting story. The reason why we want to have redundancy. Right now it's only relying on one set finding one set of what's the best case scenario is you don't want to have the point, but you know existing fighting story already have so the best case scenario is to try to take that system. And that's actually what we develop right now actually. So there's a new version for the website, there's a new version for this. Both of them are running work on
Just to understand, so I understand every flight, or like you mentioned, they will come up with their own default. How many codes or how many flight data can you store before it becomes full and you'll
That's the beauty of fast story. In this sticker, you have a like 53 foremost flight controllers. When the customer can add more functionality. So right now we have almost infinite amount of storage you can use. And there's more than 100 flights that have been stored according to this model. So if you want the video about this, say I want to see what's happening. I'm just going to go through the replay archive, and there's, you can see, 1 5 and most of them are filled, some of them are empty, but still, they're filled. One of the flights, I remember, honestly, I see the flight. You see here, there's a system. So what's the idea with this? We want to start but the issue is sometimes you need to retrieve that data. If you want to see what happened to that data. The website gives us 10-to-1 ratio. So every 10 points on the card, we have one interactive point saved to the website. And this is by design to not cloud the service we're using. We have so much points on the site. Yeah, I know the code is CFP. We have two sets of that. It's almost this one. The one below is done using the website. I want to can I use you can see it will say $400, right? This was done back when we came back from summer break. So you can see, I want you just to see motion. So this one is interpreting the data, right? So now, once you have let's go for the SD card. So this one is modified. We inserted ourselves to the database using the module. The database is very highly selective, so we have to use the module. The reason why is because we want to keep everything protected. We don't want to allow people to insert data. I want you to just remember that how that fly like slow, right? You will see why this one actually good. This is the drone. So this is from the drone. You see how we can't read this because there's too much noise. So the website should be somehow streamlined for us to understand.
the real life brain is actually you simulate.
No, the drone is fly like this, but it's not stable. So these are all being modified by the microservices. So when once it moves front, you'll see it will like push one direction, then it will start to stay. You can see that left and right. Now it's speed left, then you try to adjust back to the right. Because the drone when it moves like this and then try to adjust back. Yes. So right now when it moves front, it's move front, then it will move back, stabilize itself. So to allow us as users to understand what's going on, we use the website. However, if you want for the analysis, you can still use this. And plus you can see over here by the channels, you can see what's happening. So let's say channel 1 is the pitch, you can see, oh, the drone is going front and back. And you can correlate it with this. So you see right now, it's being pushed to the front, so you see it's going to the front. That's how the system works. Because of that, it stores it and transfers it. So exactly like how a black box would work.
So this the whole website for all this you designed from scratch within this year.
This project actually was started when I was thinking about making a project for my final year. So I discussed this with the supervisor and he said, yeah, sure, you can work on something. So I already had a plan for it. So what I did was I worked on this website design, and when I saw I got the module, I started designing the shell casing for it. So once this was done, this actually phase 1 was completely done. The whole website, everything was done by the first sem, entirely, with the testing and everything. But then, during the sem break, I started to design a PCB for the project to keep it like usable. So to keep the weight off and to keep it more protected, design the PCBs and we assemble it together. Then we run the test again on it because we want to see how performance have changed. It didn't change much, to be honest, except for the different sensors we use. So once we done that, we started using this as our main project for the flights.
So your internship you did here or back in your...
I did here actually, UPM with Harrison. Harrison taught me how to design the PCB and all that. So I would say I used that case for my project. I did it under the same supervisor. They were initially going to do it outside, but they said they didn't have the equipment to build the project, so they wanted to build it in our lab. So I said, yeah, sure,
But this is very... Wow. Everything in one year is fantastic.
To be honest, if you love programming, like whatever, you just have ambition. Yeah. Even after it's done, I still have the ambition to continue.
I think there's still, I would say, a lot of unexplored places that you can but
The idea started actually because during our MP course, we tried to fly our own aircraft. And one of our aircraft, actually, part of my team, it flew away. We don't know where it went. So we had to actually just chase it around with a remote trying to find it. But I was thinking, probably my project would have been, should have been inside. It was in space. So we couldn't really get
so now, like what you mentioned, if, I mean with all your technology, you are, for example, if you lost the drone like you mentioned, now if it's implemented with whatever, I mean, tractor, within the 2 hours, you should be able to find your drone.
Because most drones, especially ours, will last around 15 minutes for flight, or 30 minutes as in airplane. So within the 30 minutes, let's say you use the flight, this one can, or this we actually can stay up to 2 hours 30 minutes. We have done the best test. And within that 10 minutes, you still have extra 2 hours to try to find the drone. And by law, all operators of drones should be within visual range of the drone. So that gives us plenty of time to try to locate the drone.
Is there an app that you can track the location of the drone or
If you, okay, I'll show you this. You can scan this QR. It's quite special. I'll show you a very neat feature we implemented with our system. So if you scan this QR, it will give you our website. This one. That one was presented already. Alright? Now, you will access the same website. However, if I go over here, and then the look you feel here, I believe. Install a Git shortcut. Click on it. Right? So you will just this one is exactly the same way, but you can go into a different mode. Once it shows up, did it slow already or? It should be on the homepage actually. On the homepage? Yeah. It's now. Oh yeah. You will see it goes directly into tracking mode. So tracking mode doesn't have all these nifty features, but it just has just the map. And you now go to this one. So you can zoom in. See exactly here. So it goes directly into this. We have thought about this actually. We said, okay, people might want to track. The original idea was to give them the entire website on this. But the best way we can do, using this app, you can directly track the drone.
That's very interesting.
And the benefit of this is you don't need to have just one ground station. Now you can, I'm connected already to this, and you're already connected. So you can still see if you have like a bunch of students with you or a bunch of teamwork done, and you want to all track the progress of what's happening. I can go ahead and live, won't pick you up, so give me the same information. So this allows us to, have more teamwork being done to analyze.
But this one is able to track now because it's powered, right?
Yes. But the cable is just there to actually the battery lasts 2 hours. So
Okay. Yeah.
it actually lasted more than 2 hours during the first one because apparently I forgot to connect this properly. So it lasted for more than 2 hours. But right now we're connecting it to a computer just to keep it online. Yeah. But it lasts more than 2 hours, just on normal battery. If we're being specific, 2 hours, 32 minutes, exactly. From 100 to 0.
But that's, by right, more than sufficient time for you to find the drone. By right.
Because by law, the operator should be within the drone range, actually. And we have done a case study as well, where we saw a video. The drone was flying using the remote signal. And then as it's flying, it got lost in the forest, small forest area. It got lost in the bushes. The drone is so tiny, you cannot find it. You cannot see it easily. So now the operator is like, okay, I cannot find my drone. Now what do I do? Within that range, this module is capable of giving the GPS tracker and will send exactly the point within a 500 meter radius. So where the tracker point is, you have 500 meters to look around. So within that region, you can still be able to locate the drone.
But with this one, it will show you the exact.
Within 500 meters accuracy. Because again, we were dealing with ESP32, so it's not that highly efficient. That's why the second phase of the project, the idea is to join it with an Pixar to get the best out of everything we have.
That will be the next phase.
Yes. Hopefully you would like to maybe see it, try it out.
It's very interesting.
This website is actually the first website we have done. There was, during the time we didn't have the replay, it was just literally a website and just having this data there, that's it. Because for this, we didn't think about replay. We just thought, okay, the user can just download the data for themselves. If you go back to this one, you can just export to Excel and then, I'm going to just read what happened. But one case we thought about was like, okay, YouTube people, when they see YouTube, they can rewind. They want to see what happened by that moment. And that's where this feature came through, the rewind feature. To read throughout that data and then rewind to where the user wanted to see. So this feature is just by normal human being. You just want to see what happened on the flight. That's why this feature is now there. It's now being placed over here. So throughout the time, it's still being upgraded slowly. There is some feature we discover, like right now this year, I'm learning some new facts, like what would you desire to be here, and then we see if it's implementable and then we implement it.
Yeah, I think it's good, but I think, like you said, there still can be stuff that, I mean, along the way, we see is applicable, then you can add it in.
That's why development doesn't stop. Development always continues.
I mean, get that faster,
Yeah, probably master with my supervisor. We're trying to explore or expand on it. Just, right now, I would say I'm pleased with it, but I'm still not satisfied with it.
Yeah, good to hear that. I mean, you still have, keep developing it. That's very nice.
So, what would you like to see from a project like this in terms of our kind of case in engineering, per se?
Actually, the I would say whatever existing problems. I think most of the things you've done kind of solve, like I would say, the missing drawers, because I do understand sometimes. Like you said, if in the forest, it's very hard to track if the signal is bad. But yeah, this one, with this technology, I think way easier to find missing drones. So yeah, the most important is really just to keep developing, I would say, the needs or what the customer wants. Yeah, it's the same for what I do. For me, I'm just the distributor for thermal cameras. Those when you see heat, especially I would say like COVID, all around the airports or ferry terminals. Yeah. So I work closely with my principal, which is the manufacturer. So whenever I get feedbacks, I'll tell them, look, the customer says they want this feature. Sometimes I think, if it's logical, I think it's a good add to the camera. I'll feedback to the manufacturer, my principals. So because I meet different customers from different, I would say industries, all the way from R&D, manufacturing, maintenance, all sorts of different industries. So each of them have their own needs. So I got highlighted them maybe one model specific for example R&D, because they need high resolution, sharp, clarity, all those. So yeah, for your case also, because you are more focused, I would say, on the UAV. I do understand that DJI is the market leader, but with whatever you are developing, I'm not sure, because I'm not the most expert in this, but I think it's something maybe DJI don't even have. So
DJI does have a very good system or ecosystem in terms. We have tried it before. They have a very brilliant way of working with their drones. However, people sometimes, like enthusiasts, like us engineers, we want to develop our own because we want to explore the horizon.
yes,
And sometimes we cannot use DJI system in our system because theirs are only set for one specific type of drone. Yes. So how do we still explore that horizon? By inventing our own tools to still be able to achieve what we want.
because I think sometimes for them they are focused on just selling. For your case, I think is continue to explore the horizon. So I think your one, if you can even come up with something better, maybe you can even commercialize in the future. I don't know.
There's hopes to commercialize, but not within this time. Because again, I'm not quite satisfied with this yet. I hope to
Until you
achieve
make it more and maybe stable. I mean, even more stable to an extent. So I think very bright future for this.
I'm really heartfelt with your recommendation.
Because it's very impressive. I mean, to see all this, very, very wow.
Thank you. Thank you very much. Within your experience, would you say, what would like you think students would want to do with something like this? Like to build upon, or what type of sensors they would like to build upon one of this? Because you said it's a modular design.
Yes.
So what do you think would be the best explore case for something like this, like to expand upon?
Actually, for your case of the like auto identification, that one is I think if not very convenient already. Maybe now I can't think of what else that can modify that one. I think that one is already very flexible for the end user. It's like plug and play. It's like auto detection. It's very good already. Because rather than it's like fixed for one, yeah. So it's super helpful. I mean, for the time being, it's good enough. But this one maybe for you also to explore what you can add on. But I would say user friendly is the most important thing as well.
The aims actually for user friendliness is the first we have the manual supported by 4 languages.
Yes.
And again, this is all you need to communicate or use this device. This what comes over here is what you need. So this one, the screen sits over here. There's already the charging cable. It comes with the battery on the screen. And plus, you already have the light connector and the screwdriver to unmount and mount the different types of light. So, realistically, this is everything you would need to use this project.
But this one, it is connected to the drone. How is it connected? What's the connection type?
So this one we're just using an Arduino Uno over here.
Yep.
But should be the Pixar actually. This one is where the Pixar connects to get the information. So this one is a direct connect, but this system will just also read the signal as well. So it's only mounted by the signal and ground wires. The positive wire is already directly to the Pixar. So because this one works by reading the battery percentage. So if there is, I would say, if I connect it directly to the system, it will say, oh, there is no battery, because HP can only do 3 volts.
Yes.
But the Pixar does up to 5 volts. So to protect the AC and protect that, we split the power cable, drum and signals there. And then the LiPo battery connects to this. So in cases, this one goes directly to the Pixar. This one will go directly to the port. And this one will go directly to the battery. So it's a battery split. So the battery goes here, and goes over there. We have done a study bench actually to see how much the battery will discharge. Because we were worried at first, like, would the study bench damage this? Because, motors at high amps or voltage is being used. So when we did the test, we saw that it's up to 3 volt, not 3 volt, sorry, 3S battery, and it can handle all types of current for different types of motors. So that's the benefit of having this system. It doesn't pick back of the power, so the power is not being used up. By maximum, it's microamps, not even much being used, and also the voltage is not being depleted, so the battery still operates as if nothing is there. However, we're just getting that information. So,
I think so far is I think very good, but I know like what you say, you can make it even better.
There is always room for improvement in my idea. There is even the box itself has a room for improvement. It's just where you can improve is where you start first.
I would say we are all human, so I mean, if we are not improving, we are just a robot. I would say robot.
Yes.
Yeah, I give you the command, then you do. Yeah.
It's also our details engineers to improve based upon what we start.
Yep. I think it's something that can be commercialized. Something that actually I think you can go against DJI.
Hopefully.
Yeah. But I mean, yeah, you need those strong backings from industrial players or not sure, maybe investors or else. But I think definitely you can you definitely make the market one day.
I really hope so because, well, as you can see, this stages took a lot of
Well,
time.
then, yeah.
Because this one alone was done mostly in Sem 2. These two were done during Sem 1 and Sem 2. So all of them, especially this part, was done by the early of Sem 2, the finalized design of it, basically.
So basically, you started this in. You mean Sem 1 as in your FYP Sem 1 or?
Semester 1 for the FYP goes throughout the studies as well. So semester 1 for our studies is also the Sem 1 for FYP. So this was during the studies as well.
Oh, it means your very, very first semester already you started.
Not very first, but during the last year.
Oh, okay.
So this idea was actually explored during the internship. We just saw the UAVs fly, and there was an idea. If planes have the black box, why can't UAVs? And we saw there is systems out there. It's just either too expensive or
Not as efficient.
not as sufficient as you said. We actually compared the cost of this, and we said there is a different team who is using a radio telemetric system. We asked them, okay, how much does the telemetric system cost? They said 280. This one is 300, but the thing that we're missing is that system needs a ground station. And
You don't need one.
yes, and we looked at the specs. We saw, okay, let's see what's the minimum we need for a ground station for the setup. It's within 3,000 ringgit for a laptop that's running Windows and within enough RAM and SD card, SSD. So we saw that and we said, okay, 3,000, 3,280 versus 300 ringgit, and that's it. It's a standalone, completely standalone system on its own.
I mean, if some customers they can see the differences. I mean, some they just want cheap, so they just plainly look at price. So some they know what they want, like I want these features, everything. They don't mind paying much more. Same case for when I deal with my customers. Do you want the features, or I mean, do you want the specs or whatever do you need, or do you want just plain your price?
Yes. And even when we did this, I asked my supervisor to see his phone.
Yep.
The module was online in Saudi Arabia, and he could see what's happening in Malaysia.
You can do that.
Because this one is relying on SIM card. It's the same one in your phone, so even if you go outside everywhere, it still will work. So the benefit from this is actually it's literally unlimited. Wherever there is a cell tower, you can just use it.
So you automatic switch from carriers to carrier.
You can not automatically, but
Yep.
there is a SIM card right here.
Yep.
So you just get it out, change the SIM card to whatever carrier you prefer, set it inside, and you're ready to go. It's plug and play right away.
Okay, then this one solves more issues.
Because radio, again, you have to be within range, and as you see from the video, you have to be within a specific amount of range.
If not, you can't pick up the signal anymore.
It's literally like if you see a small range, look over here, you can't see it, but the module is still capable of reading it. So we were actually stationed over here at this point, right? So you see the distance over here. Then it picked up over here, and the module still picked up all the whole route.
Yeah. This one very useful.
This is one of the top priority, and then the second priority is Pixar. When we read the mission planner review, it's not very readable actually. If you've been asking like, okay, what's the roll rate? To present you with something like this, it won't present you with specific data or like just your full horizon. No, it will just present you this. So from that you have to analyze. Okay, pitch left and right. It doesn't even say. It will just show you this graph. So you need to know where did I pitch left, where did I pitch right.
I see.
I have to see where did I go. But with us, we analyze everything and give it to you. And then even with that, even AI is being introduced over here. So
Everything.
this one is the this one is like you can see it. It says there's a steep bank, there's banking, and it's a normal. This is designed for a foam aircraft, which is the ones we use in faculty today. So if you see like how stable, the altitude is 31, so naturally if your aircraft flying low, so it will tell you to climb up. The altitude and everything is sent by the GPS. The IMU only gives the control and yaw. And the yaw or the IMU is actually using a filtering process where we take the first contact point from the GPS and then merge the IMU to start rotating beyond that point. So this is the compass, and this is where it will add or define where the aircraft is going. So even if then, you see this one is a bit of a higher pitch for foam, so it will say coffee.
Actually, I mean, all of this is
Even with that, you can still see how the flight appears. And
you I mean, refresh as you.
it will just, you don't even need to change the website. It's literally there and you just,
All in one already. Very impressive.
and also we support
That's
developers,
nice, yeah.
We have to support our own.
Yeah, actually that one is very important. I would say a lot of, even personally like myself, I like dark mode. So if there's no dark mode,
It's
nah,
kind of breaker, yeah, I know.
very nice. Yeah.
And everything has been thought about for this project. There is the user experience, how the user will experience it, and in terms of how easy is it to install. And we've done a video, 10-minute video of how to install this actually. And the user, if like the user amount is not sufficient, you just download the video, see. It's really simple. The module will come like this actually, but let's say if it's dissected fully, so we literally did that video where we put everything piece to piece and put it on there.
If you ask me, the UI UX is very clean. I think easy to access also. I mean, from just now you go from one option to another option. It's very clean.
There's no refresh, there's no, it's directly whatever you set, it will send to you.
And it looks smooth as well because sometimes it's loading. Yeah.
This one is done by the front end, the selected, and it's retrieving the data from the backend. The backend is Python based because I am very expert at Python, not very well with website design, so the backend is built on Python, including the database, which is an SQLite database. So the table name is the flight code, and then everything else is set into it. And then this one, when based on what you select, it will like, okay, this one, like this flight. But based on what you select, it will read the data again for you. So this one is by line actually. No, have you used the 3D printer before?
I've seen before, but never used before.
In the 3D printer, it will show you there is a percentage of like how much is done. But below it, there is a small text that will say this is by line. So the exact same method is being used here. It will read it by line.
Okay.
So every small data it will read and then present it back to you. That's why you have everything working as seen. And then once that's done, it will present to the front end. So this is why this is flush. As you can see, like you just click, everything is done flushly, and it's just retrieving. So it's still there.
Yeah, it's very responsive. There's pretty much, I would say no lag or almost instant.
The only lag happening is just from the hardware system. But other than that, everything is very clean.
I would say software-wise, this one also it looks good. Very clean. Nicely, I would say everything that I want to see, I think it's already over there. Looks very nice.
Thank you very much. It actually, we decided first with the Python program app, but we then said we wanted to be more accessible, so the website. We also have done a lot of projects using website. Just started Kickstarter because of this. One of them is based on one of the courses I have done in engineering. So if you need something, you will always remember the link for it.
Yes, definitely, because you are the one that put in all the hard work. So
Yes.
yeah.
Okay. This is a GUI based. It was a Python program we sent to a website. So it's actually a Python based website, and it will the GUI like similar to old design. Like remember the monitors we had before, the CLI.
Yep.
This one is similar to that design. So you would see different parts of it. And the idea why I wanted to transfer from Python app to this is because of this project, actually.
Right. So you, I mean, most of the stuff we are using should be from Python. I mean,
Most of it is from Python. The backend is just really from the frontend. So the backend, frontend is actually we had a lot of use with AI to navigate through, but thankfully everything came out well.
I think definitely this is I would say a good product now. You definitely can commercialize next time. Eventually,
There is
yeah,
hopes for commercialization.
one day.
Yeah. Indeed. Thank you very
Honestly, very impressive.
Yeah, I'm actually pleased with myself, but again,
Yeah,
there's more room for improvement. There's
I mean,
satisfaction.
1 year is a lot to achieve already.
I heard that a lot, but you know, if you have the passion, just do it.
Maybe continue the masters. Yeah.
So many challenges. Ever wanted to see the website you already have installed?
Yeah, I think I wanna.
You can take a picture of the QR, so it will direct you. Because the one you have is actually just the raw website, but the ones we have is the /project part of it. You can also take this one. This one is a website, this one is And the idea for this screen, actually, to replace for the remote, came through while we were developing it. We were like, okay, remote can be, you can have the exact same remote, it's very common. But this screen is actually ESP32 screen as well. So these two are linked by an IME code that both of them identify with. So no other ESP32 device can hijack into it.
That's right.
That's the idea.
Yeah.
Yeah, that's the idea behind every step. So every time we do something, we ask, can we improve it? The security for this, we wanted to improve. So that's why we came up with this screen.
That's, yeah, I mean, that's good. I mean, like, you say, there's one, for example, like the security. This is something you tackle on. It's very good. I mean, user would want all this kind of enhanced security, like not simply get hijacked.
Yeah.
So it's very, I mean, well thought of. But I don't know what else you still can add on. But I think this is, more, I would say, very sufficient for, I would say, day-to-day use.
That's the other idea.
Very nice.
Thank you very much.
But I mean, I like the whole setup also. I get to see the actual thing, get to see all the modules. Yeah.
The reason why even this has been studied, because when we presented before, we always thought about, okay, what the presenter is going to be.
Yep.
So if you see, the iPad is not connected to anything. That's why we have the website on it. But this is connected to the laptop. But we're only presenting a video here.
Yes.
So people don't think, oh, the website is directly connected to this. No, it's two separate things entirely.
But yeah, I mean, I like the whole setup is nice. Like you get to see the full experience.
Yes, that's our aim. We want to show what you have done
Yes.
in terms of the work, in terms of achievement.
Yeah.
Overall, this is took time and effort.
Yeah, I mean I feel the pain.
Yeah.
To do something like you want to impress, it really takes time and a lot of effort. So I can say both I would say both the software, hardware really honestly it went beyond my expectation. Yeah, not because of what, but it is from through the explanation and I mean the experience is very nice.
Whenever I see my work, I always think,
You feel happy.
I feel happy with what I achieved, true, but I always think, what could be done more?
That, yeah. Very nice.
Thank you very much.
I think I'm more than satisfied. Yeah.
Thank you. Your satisfaction is really bringing me joy.
I think, yeah. Try to commercialize this. I mean, in the future, lah.
No, that's the whole aim. Inshallah, to commercialize it.
Very bright.
That's why there's the user manual. Like everything is done. So that's why. That's the whole one. That's why we have the user manual, we have the boxes. That's why we already set the idea for commercialization. So how do you achieve it? Is by readying up.
One day in the future.
If you would rate this product as a product that you would use out of 10, what would you give it as a rating for your personal enthusiasm, I'd say?
I mean, on display like that, I'll easily give it at least a 9 because number one, easy, how to say, it's straightforward. All the data I want is all there, plus whatever. I would say there are additional here and there where I don't know, maybe like even if I don't even have, and they're such a big brand, so. I think everything is like meticulously, like everything is designed for user experience. It's very beneficial to whoever is going to use this. So carefully thought, very well designed.
I'm really glad with your ratings today. Actually, it gives like support towards what you see.
Yeah, because I mean, as I deal with so many different industries, I also, even for myself, I want to propose like the best option, best everything within budget, specs. So this one, I mean, I've never played like the drones or what, but from this one, I think it's very good for the user.
We always thought, not just for normal user experience, because we as engineers, we already know, but what about the others? Enthusiasts, but they haven't done anything in it. That's why there's AI, there's a lot of aspects, to keep it going. Not just for us, but for everybody who wants to do it.
Very nice. But yeah, all the best in continue developing. Very bright future.
Thank you very much. And sometimes even like after it's on,
Data is still there.
because some systems like will cramp up, right? They will like cramp up all the data, so sometimes it's very laggy.
Yes.
However, the performance is still there.
Yeah, I see almost instant response. There's not any delay. Overall, I'm satisfied, but I think I still need to go and judge the others. But I mean, I can pass you through.
I would love that actually. I'll need to send you the video, right?
Yeah, I mean, just
I'll send it to you. Is there WhatsApp on this one?
yeah,
Okay, I'll send it to you via WhatsApp on this.
Sure.
YouTube is okay?
yeah, no worries, all good.
It will be a private, don't worry. I won't post this. It's just a private link for my supervisor and for you as well.
I mean, yeah, it's good. At least your supervisor can see the whole thing.
It's because even when we all present, we want to keep the video because we want to see, we want to reflect back on what happened and how we can deliver it. So based on the feedback today, you might maybe in the next couple of months, you might see some different changes based on your feedback.
Very fast. Yeah.
Because we take user feedback. It's not just about how we want to develop, we want also the users to see. Some of the feedbacks are actually about this, the channel, where they say, okay, I don't understand like what each channel means. The issue is you can't say, okay, channel 1 is pitch up at each channel, because even for a remote like this, you can't change the channel.
You can change it up. I mean, individual, like
Yes.
what the settings you have.
So that's why we thought about it. We said, okay, what if we combine with the FAT decoder? So whatever channels being here, it's already linked to the FAT decoder. So that's one improvement we already thought about. That's why we want to link the FAT decoder.
Thanks for coming.
No problem. But I think I cannot finish charging.
Why?
I don't know. I stopped at every room too long.
Hey, how many more do you have?
Banyak oh. I think 1, 2, I think 3, 4.
Okay.
I don't know, I can finish or not.
No, you have to.
Okay, I have to. Yeah, but maybe I mean I hope to see even better by then. Yeah. Thank you so much. I think. Yeah, no, I mean thank you for you also to slowly explain to me.
Of course. We can explain our own project. There is a very wrong issue.
Because that's actually FYP, this presentation is like to show all the hard work and like be proud of. Yeah. So yeah, me too. I mean very thankful to be able to see this. So.
Thank you very much.
Thank you. See you. Okay. Thank you so much. Good luck.
Thank you.